Hi, welcome to the second part in the series of DirectX tutorial for Windows 8. In the last part, we wrote some basic code to bring up a window in the Metro or modern environment. And in this part, we will clean up the code that we wrote in the last tutorial just a little bit and see how we can initialize Direct3D. Let's bring up Visual Studio. Last time we wrote all our code in one single file, main.cpp, which can get a bit ugly. So I have split up the code into different files based on the classes that we had created. So we had created DirectX view and DirectX view source classes. So I created the corresponding CPP and header files. As we saw last time, in the main function we need to call the core applications run function and pass to it an instance of iframework view source that we have created. So we created DirectX view source. So we are creating and passing the instance of DirectX view source. DirectX view source, as you know, is very simple. It just has one function, create view, and it is supposed to return the instance of our view class. So most of the work obviously is being done in the view class, which inherits from iframework view. So we created DirectX view and we implemented the functions that the framework calls. The code, as I said, remains exactly the same, so you don't need to worry about it. There's just a bit of refactoring, that's all. I'll close the solution and we'll create a new copy of this solution for our second tutorial. So I have snipped the video and created a copy of our earlier solution so I can maintain a solution for each stage of the tutorial. We are now ready to initialize Direct3D. There are two basic interfaces which are required to interact with DirectX. One is device, and the corresponding interface for DirectX 11.1 is D3D 11 device 1. The another interface that we require is device context. It's D3D 11 device context 1. So why do we need these two interfaces? We cannot write some code to access the video card directly and assume it will work for all video cards. We need a common standard layer on top of the video card which deals with internal differences and provides us with an abstraction. The device provides us with an interface through which we can access the video memory and allocate resources without worrying about how it is handled for different video cards. So we will be using this unified interface for allocating resources and accessing the video memory. So basically we create resources on the device, but we also need something which sets the context to that resource to indicate where that resource would get used in the pipeline state and issue rendering commands. For this, device context comes into picture. This will be more clear as we progress through the tutorial. So how do we go about creating the device and the device context? Turns out there's a pretty simple function. Looks a little complicated, quite a number of parameters, but we'll see if we can ignore most of them for simplicity's sake. So the function name is D3D11 create device, and it will help you to create the device and its context. Its immediate context to be precise, but we will go into the details later on. Actually, we can have more than one context. So let's go back to Visual Studio. Okay, so we would be writing the initialization code, uh, which would be common to all the games that you would be writing. So let's create a base class which would do the initialization. Um, let's name it Direct3D base, which is the same name as MSD samples use, and I toned out their creativity. So okay, so let me zoom out a bit. Okay, let's name our class. Okay, we already named our class Direct3D base. We'll make it abstract. It would have a constructor and what functions would we require? Okay, so this Direct3D base actually needs to access the window on which it will draw. So the window that we created in the last tutorial, the core window instance. So we'll write an initialize function. We'll see how we would be using this window instance later on when we write the code. So I'll just say initialize and core window. Okay, and we would also need to store it somewhere somehow. So let's make a private variable, sorry, Windows UI core window m_window. The next function that this class would need is where we would be creating the device and the device context and some more resources later on. So let's name it create device resources, and so this is going to create an instance of ID3D11 device 1 and ID3D11 device context 1, as we had discussed. So the namespace for that is Microsoft WRL. Okay, I'll need to include WRL/client.h. So okay, cool. This is required for the smart pointer, the COM pointer that we have. So pointer to ID3D device, sorry, D3D11 device 1. So the naming convention is like ID3D11, that's DirectX 11. Device 1 is for DirectX 11.1. So for DirectX 11, the interface would be ID3D11 device m_D3D device. Also, as you know, we will require to store pointer to ID3D11 device context, sorry, context 1, and D3D, let's say context only. Okay, I think I need to add one more include file, that's d3d11.1.h. Okay, so I think we are done with d3d base.h for now. Okay, so let's implement this. I'll add new item, the implementation file, direct3d base.cpp. Okay, let me zoom out again. Okay, we don't need this. Sorry, include pre-compiled headers, include the direct3d base.h file that we just created. Let's bring in some namespace that I would require. It's getting a bit tedious to fully qualify all the names. So we'll need DirectX. We would need DirectX is enough. Microsoft WRL. This is all for the Windows stuff. Namespace Windows UI core using namespace Windows Foundation. I'm not sure whether we would be requiring all the namespaces, but anyways, I'll go ahead. Okay, graphics, display. So let's write direct3d base, the constructor. Okay, let's keep it empty for now. I don't like it wasting space. So. Okay, the next function is direct3d base. What do we write? Okay, initialize. So initialize with an instance of the window. Why is it red? Okay, void. So we'll just assign the window reference to a private member variable. So here's the important function, direct3d base and create device resources, where we will be creating the device and the device context. So let's see again what all parameters it requires. It requires an adapter, driver type, software, some flags, feature levels, this count of feature levels, SDK version, and it outputs the device, the feature level, and immediate context. Okay, I'll just copy this. So let's write this function. Okay, there's one thing that we need to be careful about is, okay, first let me write the function d3d11 create device. The first is adapter. So there could be a case where a machine has multiple display adapters and we have to choose one of them. So we need to tell DirectX which adapter to choose. But in most of the cases there's only one adapter, and so if we specify a null pointer, DirectX will automatically choose an adapter for us. So we'll keep it null for now, and in most of the cases it would remain null. The second parameter, d3d driver type. So this would be d3d underscore driver underscore type underscore hardware. So That's because we need the hardware driver, not the software one. Next pointer is software. So we'll specify null pointer here. Actually, you can write your own rasterizer engine or software engine, but yeah, don't do it. Next one is we won't be using any flags as of now, so I'll keep it 0. Feature levels, we won't be using it, so null pointer. And this is the count of feature levels. We have specified null, so the count is 0. Basically, the feature levels are required to define the set of DirectX hardware feature levels this program would be supporting. So we would have, actually we will create an array of feature levels, and we'll specify their first 11.1, then 11.0, 10.1, 10.0, and the lowest level that you would be supporting for DirectX, I mean Direct3D. Keep it null, and anyways all applications are assumed to support 9.1, so we don't require to set this one. The next is SDK version. So we are using DirectX 11, so it would be SDK underscore version. If you're writing applications for Windows Store for the Metro environment, you must specify DirectX version as D3D11, otherwise it won't work. Okay, now the output parameters. So the first output parameter that we get is ID3D11 device. Cool. So, and we have already defined a variable. So let's pass it to it. This is device. So m underscore D3D device. The next parameter is the feature level that it will output. Basically, as I mentioned earlier, you can specify the minimum set of feature levels that your application should support. Later on, like when it will create the device and the device context, DirectX will automatically determine which feature level it would be using, the highest level, and it will return you back that particular feature level. For now, as we are not using it, we will be adding it later on, but for now I'll just put it as null. The next is immediate context, which is our context. So we have already created a variable id3d context. Okay, so we are done, but there's a slight problem. If you see our header file, you would notice that the interface is id3d11 device 1, and the type that this function is returning is id3d11 device, not id3d11 device 1. Basically this is a DirectX 11 function, and there is no function like this. So what do we do? How do we get a pointer to id3d device 1 instead of id3d11 device? Sorry, I don't even remember what I said. So how do we get a pointer to id3d11 device 1 instead of id3d11 device? Turns out we actually need to create id3d11 device and not id3d11 device 1. We would later convert this interface to ID3D11 device 1. But for now, let's declare device as ID3D11 device, and same goes for context, ID3D11 device context, and sorry, context, device goes here, context goes here, and our Visual Studio is happy with that. And as these are all COM interfaces and we are using the smart pointer, the COM pointer, it's actually very easy to convert ID3D11 device to ID3D11 device 1. To know exactly how it does, it's actually out of scope. If you really want to understand, just read through all the COM tutorials and come back maybe a year or two later. But for now, it should be, to convert it, it should be as easy as using the as function. So, and m underscore d3d device, and similarly for device context, and m underscore d3d context. Okay, so these DirectX 11 pointers are converted into DirectX 11.1 pointers, and we are done with creation of our device and device context. Take a short couple of minutes break from writing code. Imagine a 2D world. We have our computer screen and we want to draw a circle on that screen. So how do we go about this? So for that we actually need to create a memory area. Let me draw it in some different color. Okay, a memory area which is of exactly the same size as our computer screen, pixel by pixel, and we'll present this to the screen, and whatever is on the memory buffer will get drawn onto the screen. So to draw a circle, we will just highlight the pixels that we want to draw in the memory with the color that we want to draw and present it to the driver, and it will draw it onto the screen. And suppose if you want to do some animation, we will clean the screen, draw it again with the circle just a little ahead and present it to the screen, and it will draw whatever you have in the buffer. So ball moved just a bit ahead. We can do it by writing to the memory buffer every 40, 50, 60 seconds, whatever frame rate you want, and the memory buffer will continuously be written, will be drawn onto the screen, and we will see the animation. But there are a few problems with this approach. There is tearing and there is shearing. Let me explain it to you. So I'll just clear this. Let me move this a little ahead, and I found some nice picture to take a break from all the 2D circles that we have. Okay, suppose we want to draw this particular ball and we want to draw it here. The way the screen draws it, it starts reading from here and reads line by line from top to bottom, left to right, and keeps drawing. Now suppose we have our ball here and we present it to the screen. So on the screen a ball will get drawn, first this part, then this part, then this part. If you see the actual ball, it will first draw this line, then this line, then this line. Suppose on the screen we have drawn up to this part, but your computer being more faster, you, for the animation that you want, you move the ball, you clear the screen and move the ball a bit ahead. Now the computer has read up till this line, which is the old buffer, the old data. Next line is actually the new data, and new data, the ball has moved a bit ahead. So what would be the final result? The way it would look is, okay, let me, I need to have a GIF, but anyways, I can manage this. So it will draw from here onwards from the second buffer where the ball has moved a bit ahead. So this is what would get drawn. This is called tearing. Tearing while watching movies on your computer or while playing games. So how do we minimize this tearing? So to minimize it, we'll apply a technique which is called back buffering. Basically, instead of having just one buffer, we will have two buffers. Now when your computer screen is drawing, it actually uses a pointer to the buffer, which points to the starting location of the memory buffer. So from the starting location, it will keep drawing, and our software which is rendering it, we will not write into this area, because we might write when the screen is in the middle of the refresh. So we'll write it in a separate memory area. So a ball a little ahead, we will draw it here in a separate memory buffer. Now after we have drawn this, what we will do is remove this link from here and point it to this buffer. Now the screen, when it will ask for the starting address, it will get this address and it will start drawing the ball just a little ahead, the new frame. And what about this buffer? This would be our back buffer now. Here we will draw the next scene. So ball a little more ahead, and then we will switch this pointer to point to this buffer and remove the link here, and we'll keep doing this. So this would avoid or minimize flickering and tearing. The active buffer which is getting drawn onto the screen is called the front buffer, and the other buffer is called the back buffer. We can have, here we have only two buffers, but we can have many more buffers, and we'll create a chain of buffers, but there would be only one active buffer which would keep on changing, because we will keep changing the pointer to point it to different buffers, but at a time there can only be one front buffer. We can ask DirectX to create this chain of buffers for us. This chain of buffers is actually called swap chain. Creation of a swap chain is pretty low level operation requiring access to the display adapters APIs. To help us create a swap chain, there's a different set of interfaces, and it's called DirectX graphics infrastructure. There's a function called as create swap chain for core window. So what this function does is like creates a swap chain for the window that we created in the last tutorial, the metro window. So roughly it would take as input the metro window instance, then some description about the swap chain that we want to create, and output the swap chain that we want. And this particular function is a part of the interface which is known as DXGI. DXGI is DirectX Graphics Infrastructure Factory 2. Now, how do we get instance of IDXGI Factory 2? It's not as easy to get the instance of the factory, but we can get it via the instance of the graphics adapter. So the graphics adapter interface is IDXGI adapter, and apparently its parent is the IDXGI factory 2 that we require. So if we call get parent, there's some COM stuff which is getting into picture, but I don't have the capacity to explain all of the COM related stuff, so I'll just skip it. So this get parent function would return us the IDXGI factory 2. We need to specify what kind of parent, so it would be view ID of IDXGI factory 2. Yes, something like that. So this will return us the IDXGI factory. But apparently we don't even have an instance of the adapter. If you remember, when we created the device and the device context, the first parameter that it expected was the IDXGI adapter, but we specified null over here. So we let DirectX choose an adapter for us, so we didn't have to create an adapter. Now DirectX did create an adapter, but how do we get that adapter after we create the device and device context? Apparently it's not that difficult. Okay, so there's one more interface coming into picture, which is IDXGI device 1, and it has a function get adapter, which will return us our adapter, that is IDXGI adapter. Now what is this DXGI device 1 interface, and how do we get an instance to that? All this stuff actually makes DirectX a little complicated, but later on you'll realize it makes it a bit flexible. IDXGI device 1 is actually our device that we created here. So our device, if we use the same magic as we did before, the magical as function, and so this particular function will return to us the IDXGI adapter, sorry, IDXGI device. Even I'm getting confused now. A quick recap. So we already have our device, we call the as function and get IDXGI device 1. Now we have GI device 1, we will call get adapter, and we will get IDXGI adapter. Now once we get the adapter, we have to call IDXGI adapter get parent UUID of IDXGI factory 2, and as output we get DXGI factory. And finally DXGI factory has the function create swap chain for core window. So I'll just add comments to see the flow. So first what we have to do is from the device we have to get the IDXGI device interface. Next what we have to do is from IDXGI device we need to call get adapter and get the DXGI adapter. The next step is to get the IDXGI factory. So from DXGI adapter, so from DXGI adapter we call get parent and we get the DXGI factory. Now once we get the DXGI factory, we have to call the create swap chain blah 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 function with the device reference, the window or metro window, description of swap chain, and as an output we will get our actual swap chain. So let's write it. So our device is m_d3d device. We call the magical AND function, and as an output we get the DXGI device instance. We also have to declare it, so let's declare it. It's IDXGI device 1, a comp pointer, DXGI device cool. Visual Studio is happy. Now we got the DXGI device. Now we have to get the DXGI adapter. So we need to call DXGI device get adapter. So this will return the adapter which DirectX created for us. And DXGI adapter. Let's declare it. Comp pointer to IDX. I keep forgetting the interfaces. Anyways, DXGI. Let me copy. Okay. The next step is to get the factory from the adapter. So DXGI adapter get parent. We need to specify the interface for the parent, UUID of IDXGI factory 2. sorry, and it will output DXGI factory. Let's declare our DXGI factory again. DXGI factory 2 DXGI factory. Now the final step to create the swap chain. So DXGI factory has a function called as create swap chain for core window. Core window is only for metro environments. You can, as you can see, there's like create swap chain for H-wind, but we are in the metro environment now. So create swap chain for core window. The first parameter, the device, we already have it. So MD3D device. Okay. The next parameter is the window, which I hope we saved. Yeah. So which is M underscore window. So M underscore window. But there's a bit of a problem. We need to cast it to I unknown. Don't ask me why, it will take a long time to explain, but I'll just cast it. So I'll use reinterpret cast M underscore window. Okay, now the next is the swap chain description. So basically it's a structure DXGI swap chain description 1, which is what it is expecting. We need to create this and fill it with some values. Right now let's assume we create it by name swap chain description. Very creative. Okay, DXGI output be restrict to output. We don't want any restrictions, we want to allow it on all displays. So specify null pointer. The things that I'm ignoring now will be clear more later, and we will fill out what we are actually ignoring at this point of time. Okay, the last is our object, the swap chain object. So we'll need to create a member variable for this because we'll require it later. So I'll say mSwap chain. Actually, let's create a variable now for m underscore swap chain. I'll go to my direct3d base.h, our header class, and as usual I don't have namespaces, so okay, com pointer. The interface for swap chain is IDXGI swap chain 1, m underscore swap chain. Okay, I'll save it. Go back to our direct3d base.cpp. Okay, still it's showing a lot of wigglies. Visual Studio is not happy. Okay, so we have passed here, what is it expecting? It's expecting a pointer, and we have passed a com pointer. So we can just call .get to get the address, to get the pointer. So yeah, Visual Studio is happy. Now here we forgot what to cast it into. We have to cast it into I unknown. Again, some bit of com, I'll ignore. Swap chain description, it's not happy because we haven't created it. So let's create it. Let's get rid of all these crappy comments. This is not the way to write comments. Okay, so let's create the swap chain description. The swap chain description is DXGI underscore swap underscore chain description 1 swap chain description. Let's initialize everything to nulls and zeros. So is equal to 0. Okay, now as we discussed some time back, the swap chains height and width should match exactly to the window's height and width. So the window that we created, the core window in the metro environment. So somehow we need to find out what is the height and the width of the window that we created in the metro environment. So width is equal to something, swap chain description dot height is equal to something. So how do we get the height and width of the window? We have the core window instance, m underscore window, I guess. Yeah. There's a property bounds. Let's assign it to bounds. Bounds is actually a rect structure, which if you go to definition, you'll see bottom, left, right, top, height, width, and xy. Okay, so the width is bounds dot width, and the height is bounds dot height. Basically, this is the metro environment whose width and height is not exactly the pixel width and pixel height, but for the swap chain description we would require the pixel width and pixel height. But metro environment has its height and width in device independent pixels, so we need to convert those device independent pixels to actual pixels. There's a function for that. Convert device independent pixels to actual, maybe 2 pixels, bounds dot width. Again bounds dot height. Turns out there is no such function, convert dips to pixels, so we'll have to write our own. So let's declare this Direct3D base. I think, okay, make it protected maybe. The function name is convert dips to pixels. It would return float, and it will take as input float dips. Actually, let's make it public. Okay, let's write our function now in our Direct3D base.cpp. Sorry, the font was, I'm not sure whether you were able to see it or not. I'll just wait for a while. We just added the signature for convert device independent pixels to actual pixels. I'm not sure whether I copied or not, but anyways. Okay, let's implement this. So virtual float DirectX base, no, Direct3D base, 3D base, convert dips to pixels, takes as input device independent pixels. Let's declare float constant dips per inch. So there are 96 device independent pixels per inch. Basically, device independent pixels is a concept that was created so that irrespective of the resolution, we see the same size of text and any drawing that is being done. That's for the metro environment though. For DirectX we'll need to convert it into actual pixels. So no matter what the resolution, 1 inch would always contain 96 device independent pixels. So we'll use this to convert the windows width and height to actual width and height. So we have to do whatever the width or height is into display properties logical DPI divided by device independent pixels per inch plus 0.5. Don't worry about this plus 0.5, it's just for rounding, which I'll be adding now. Floor. Okay, so it's basically it's just this display properties logical DPI is if you see, oh shit, okay, it's the number of pixels per logical inch of the current environment. So open my notepad and for example, if our window width is 960 returned by the bounds.width, so basically it's 960 device independent pixels, which are not actual pixels. Now there are 96 dips is device independent pixels, I'll call it dips in short. So there are 96 dips in 1 inch. So if our width is 960, so we just do 960 divided by 96, so we get it's 10 inches long. Now there's a property, this one, display properties logical DPI. It actually tells you DPI means dots per inch, that's the actual pixel. So based on the resolution this value would be different. So for example, there are 10 dots per inch or 10 pixels per inch, actual pixels per inch. We just multiply it by that, so logical DPI, and we get width in actual pixels. So 10 into 10, that is 100 pixels wide. Where is the exclamation mark? Okay, swap chain. Okay, the next property in swap chain description would be format. So this tells us how the data is stored. Let's see. So we would create a buffer, and for simplicity, let's say it's, I don't know how many lines I would be able to draw here. Okay, 1 2 3 4 5. Let's say width is 5 pixels and the height is 1 2 3 4 pixels. Now this particular area, how the data would be stored for each pixel, that is defined by the format. So normally we would be we should be able to store the color and its alpha for transparency. So I would have something like first 8 bits, next 8 bits, so 8 8 8 and 8. So this for say R, G, B and alpha, and each would let's say would be 8 bits. So this would be 8, this would be 8, this would be 8. And the format of the data inside, because inside there would be a number, is it an int or unsigned int? So that also we have to specify the type. So okay, we have some enumerations for that. So there is one enumeration DXGI. This is the most common one. Underscore usage. No, it would be format. Underscore format. So this is the most common one. B8. B8 means it's 8-bit wide. Then next again we'll need more 8 bits. For G, more 8 bits. Alpha, more 8 bits. It says B, G, B, R, G and A, but actually you can store anything you want inside it. And what is the type of that? We can say unsigned int. Oh, actually unsigned int is not allowed. So normalized one. We'll get back to this a little later. Now the next property that we need to set is say buffer count. So we require 2 buffers, so our buffer count is 2. There's also a couple of other parameters that I need to set. One is called stereo. Stereo you would not require it unless you want to make 3D games, but we are not doing it right away, so let's keep it as 0. Sorry, as false. Now swap chain description dot sample disk dot count. This is for anti-aliasing and multi-sampling. Right now we are not using anti-aliasing or multi-sampling. We'll keep it as 1, and also we can describe the quality that we want for that. So we'll keep it as 0. We want the worst quality for this. Okay, buffer count we have specified. One more thing that we need to specify is the swap chain descriptions buffer usage. What this buffer would be used for. So as you know, we want to use this buffer to render our data into output target. So the enumeration for that is dxgi usage render target output. I think okay, there's swap chain description dot scaling. So this says do you want scaling or not. Right now our buffer size is exactly same as the screen size, so we actually do not require scaling. But suppose it is smaller, then it will draw on the corner. So if it is say half the width of the entire screen, and when we go to full screen, it will draw our graphics only onto the top left corner, and the rest of the screen would remain blank. But if we enable scaling, then it will scale it to fill the screen. Right now we don't need scaling, so we'll say DSGI scaling none. You can say stretch for stretching it up, but we'll say none. Swap chain description dot swap effect. Okay, this is also one thing that we need to set, and especially for Windows Store apps, this has to be flip sequential. So it will sequentially flip. Anyways, there are more options that we would delve into subsequent tutorials. So our description is ready. We have provided it to the create swap chain for core window function, and our swap chain is ready. Done with the Direct3D base code for this part of the tutorial. Let's see if we can build it. Okay, so we are able to build it. Our Direct3D base class is ready. Let's implement this class and create our own concrete class which will inherit from Direct3D base, and for today's tutorial it won't have much code. In fact, it won't have any code. I'll add our game renderer class, which would inherit from the class that we just created, which was Direct3D base. Let me let's also include our Direct3D base header file, Direct3D base.h, and sorry, okay, the functions that we need now are obviously one constructor, game renderer, then there would be a function which would render our stuff, so I'll call it render, and there would be a function where we would update resources. That won't come until later, but anyways, or maybe we'll just add it later. Okay, for now this should be enough. So let's add the implementation file for this, game render.cpp. Okay, I'll start with game renderer the usual stuff. Game renderers constructor, which as of now I'll keep empty. So another function that we wrote was the render function, render. So what we need to do here is, uh, so there's a lot of code that we yet have to add, but as of now we have initialized DirectX, and in render basically we need to swap the buffers. So so basically we need to switch the back buffer and the front buffer, so that the front buffer becomes the back buffer and the back buffer becomes the front buffer. So there's a simple function for that in m underscore swap chain called as present. The first parameter is a sync interval, which we would keep as 1. I'll explain it to you in subsequent tutorials. And flags, I don't need any flags, 0. So each time I call swap chain present, it will keep swapping the front and the back buffer. Visual Studio is not too happy with this. Okay, actually we made all this private. We need to make it protected so that the derived classes can access them. Now Visual Studio is happy. I'll try to build it, and there are errors. A non-value type cannot have a public. Okay. I'll just make it protected private, and let's build it. Ignore the warnings, and the build is succeeded. Just a few more tidbits and we are done for the day. In DirectX 3D base, we also need to call create device resources during initialization. Next, in DirectX view.cpp or maybe DirectX view.h, we need to declare an instance for a new game renderer class. So I'll just a reference pointer, let's call it m underscore renderer. I need to include game renderer.h, and yeah, that's fine. So let's create the instance. We'll create the instance in initialize method. We just write m underscore renderer is equal to ref new game renderer. Now we need to also call the initialize function. The place where we would have the window instance is the set window function. So here we will initialize our game renderer class. So m underscore renderer initialize, and we have to pass a reference of the window class, so that we already have here. So we are done. Now let's see if we can build this. Okay, build succeeded, and let's see if we can run this. Okay, we can run this. So there's no change at all. All that we have done is just preparation for the next steps. In the next tutorial, we would go through the graphics pipeline and actually write some code so that we can see some effect of DirectX. At least we would paint the screen in some color, maybe blue. So see you next time then.